no things to share?
Sorry, one more thing. Is it possible that, sir, if you tell us the specific slides, like for the TMA from where we can for the TMA where we can get some help for the TMA, like the specific slides for that.
Wallah, and as I told you, I didn't read the team A, but what sort of question is there? I will expect that all of
It's
them
about brute force.
algorithms.
It's about brute force and all.
Type algorithm. It means in algorithms at the end you will be asked to either analyze or come up with new algorithms. You have an algorithm, you need to make it better. But I cannot tell you that go to slide number 5 in tutorial number 2, you will find the solution. It's difficult to say that.
I'm just asking generally.
Okay, generally is the following. Now, let's say that the question says based on Floyd algorithm. Let's say that, okay? So now, Floyd algorithm, we will talk about it today, inshallah. Now,
right.
What sort of questions there? Is it just explain? Is it analyze? Is it writing a code? Is it, can you come up with better big O? So at the end, it's there. At the end, it's there. Now, if they ask you about Kruskal or Digestera, we talked about that Sunday, okay? So talk about stack and queues and linked list. They talk about مثلا searching, binary search and sequencer. So it depends on the topic itself. Okay, brother?
Yes, sir.
And I cannot tell you that go to slide, you will find everything there. No, it's not the case in the team. Okay, let's start with Bismillah, inshallah. Today, lecture 10. Inshallah, only one meeting left, lecture number 11. Then we will see how it's gonna go because we are almost the end of the semester. So today, inshallah, we will talk about these 4 topics. Floyd, and I believe that will be the last algorithm we will talk about in this semester. Okay, then we'll talk about paradigms of algorithms like brute force. See, now you said brute force. There is very little about brute force here. Very little. It's not algorithm. Then we'll talk a little bit about what is meant by greedy algorithm, what is meant by divide and conquer algorithm, what is meant by dynamic programming, and so on. Then all of these, number 2 and number 3, just theoretical part, very theoretical part. Okay, types of problems and paradigms of algorithm. That is theoretical. Now, last one, it is very, very important, interesting, nice, practical topic. The SQL. Okay, structured query language. This is very important, especially for those who want to be programmers one day. Anyone work with SQL? SQL? None? معقول? Yahoo 269, you will graduate next semester, inshallah, or next year maximum, inshallah. That's very important topic. Very, very important topic. And I believe there is no website or no application without SQL. I believe that. Okay, anyway, let's go. Bismillah ar-Rahman ar-Rahim. Floyd-Warshall is an algorithm that finds the shortest path between every pair of vertices. Another word, if you have, like what we said Sunday, cities, Jeddah, Riyadh, Dammam, Ahsa, Ha'il, Medina. Okay, now you have some, let's say, highways, you might say edges, you might say links between these cities. Not necessarily, from everywhere you will find a path away to everywhere. No, sometimes I cannot go to Ahsa directly, but I can go through مثلا Riyadh, then Dammam, then Ahsa. For example, Now, is that the shortest path? Maybe yes, maybe no. So is there any other ways, another path? Is yes, I can go to Riyadh, then to Ha'il, then Ahsa. I can go to Medina, then to Ha'il, then Ahsa, and so on. Okay. Also, I can go to Medina, to Ha'il, Riyadh, Dammam. So we will look at, inshallah, today, how can we calculate or how can we find the shortest path between every pair of vertices in a graph. That's basically the idea. Now, the brother who asked about the team, is it talking about something like that? Finding shortest path, مثلا? Is it talking about exactly Floyd? Because some other algorithm we talked about Sunday, it's also talk about shortest path. But is it between all cities or one city to other cities? Only one city. So I need to know the shortest path from Jeddah to Riyadh, from Jeddah to Medina, from Jeddah to Ahsa, Jeddah to Ha'il, and so on. Or no, all, as a whole. That depends on the situation of them. What is the difference between Floyd and Digestera? Digestera shortest path from one node to all. Floyd, no, shortest path between all vertices. One thing more, that in Floyd, negative also allowed. So how can I have a negative distance? No, not necessary distances. It could be mathematical way. If you have tree that represents equations, for example. Okay, equation. So when we talk about x multiplied by y, okay, then it will be plus something else, but between another brackets. So that one can be represented in a tree. Which one should be calculated before which one? So now if you have here z plus w, so that one bracket should be calculated first. Then the result will, what will happen? I cannot add it to y because I have to do multiplication first. So x multiplied by y, that one, that number 2, then finally the plus. Finally the plus. So that depends on the case. So Floyd accept negative, Digestera. If there is a negative, by the way, if there is a negative, it will be calculated. But that is what? A drawback. Because that might give unwanted results. Okay, so we avoid using negative numbers in Digestera because you want to be sure that if it is going to be correct or not. But in Floyd, yeah, it's okay, it's accepted. Okay, now if V is the number of vertices, number of cities, okay, Digestera runs at V square. We could just call Digestera V times passing different sources. So it depends on number of vertices. Number on vertices. Now, but Digestera doesn't work with negative. And as I told you, even if you try to do it, it will work. Because at the end, you might just adding numbers. So if you said 7 plus 3, it means I need 7 hours from Jeddah to Riyadh. Then I need another 3 or 4 hours to Dammam. So now I can say that I will take 10 hours from Jeddah to Dammam. Now, how about if it's negative? As a calculation, it will work. 7 minus 3, 4. So does it mean that I can go from Jeddah to Dammam in 4 hours? No. That's not acceptable. Unless I use those negative numbers for something else, not distances, not times. I don't have distance in negative. I don't have time in negative. Okay, so just that, put it in your mind that negative is not used, doesn't work with digester. Okay, basically, Floyd talks about very normal things. We do it all the time. If you have cities, so then you can build a table matrix that will show you the distances between the cities. Example, Tampa, Orlando, Jacksonville. From Tampa to Tampa, it's 0. From Orlando to Orlando, it's 0. From Jacksonville to Jacksonville, still 0. So diagonally, that is zeros. It means there's no value. Then from Tampa to Orlando, 1.7. From Tampa to Orlando, 1.7. Now look at the opposite. From Orlando to Tampa. So there is another way, and it is shorter. It happens all the time. Okay, that you have two ways from to. If you go, that will be taking more time. If you are coming back, you might take another way that is shorter. Could be, okay? So from Orlando to Tampa is 1.5. No, how can I calculate the shortest path between all the cities? Notice here, what does it mean infinite? What does it mean infinite? Anyone? What does it mean infinite?
لا نهائية.
عفوا ثاني؟
لا نهائية.
هي لا نهائية. But here in my case, look at Orlando وجاكسونفيل. هل في طريق؟ طبعا someone in the chat said لا يوجد طريق, there is no way. Someone said no. It means you cannot go from Orlando to Jacksonville. There is no way. It's only one way from Jackson to Orlando. So now, in this algorithm, you will find a way. طبعا, very simple one. You will go to from Orlando to Tampa, so that will take 1.5. Then from Tampa to Jacksonville, that is 3.5. So I reach Jacksonville via another vertices. Okay, فهنا infinity, that to show you that there is no way. Into what you said is correct. Infinite means almost يعني uncountable value. You cannot measure it. Okay. Okay. Let's see now how to solve Floyd-Warshall algorithm. We did build that one. We have 3 vertices. 1, 2, 3. Considered cities, considered whatsoever. Now, from 1, 2, 3, 1, 2, 3, similar to this one. Exactly, similar to this one. Okay, 1. طبعا you can number it if you want. 1, 2, 3, 1, 2, 3. Now, from 1 to 1, 0. From 2 to 2, 0. From 3 to 3, 0. So that is diagonal zeros. Then, from 1 to 2, 4. 1 to 2, 4. Let's say 4 hours. Let's say, okay. From 1 to 3, 7. From 1 to 3, 7. And so on. So we will notice here that it is infinite because from 3 to 2. From 3 to 2. 3 to 2. There is no way. There is no edge. There is no link. There is no path. So it is infinite. So that is the original weights, original values. Can I build now the shortest path between all the vertices? Let's start. Let's start. And it is a little bit strange, but we will do it inshallah step by step so you will understand the idea. Okay, now let's look. That is the original. That is the values that I have. Now, we will calculate D1, any name, D1. If you want to calculate D1, so you have to do the following. خليها كده أحسن عشان تكون واضحة. Okay, 1, 2, 3. 1, 2, 3. Now, we agreed from 1 to 1, 0, from 2 to 2, 0, from 3 to 3, 0. That is fixed. Now, I will check case number 1, D1. It means the following: 4 the first row and 7 will remain. And 1 and 6 will remain. Okay, so you will, since you are in 1, row 1, column 1 will be fixed. Will keep the values. Clear? D1, row 1, column 1 will keep the values. Now what is left? 1, 2, 3, 4. 0, 0, it's given. From 2 to 2 is 0. From 3 to 3 is 0. So what is left? That one, 2, 3. That one, 3, 2. Now, the idea. Can we find a smaller values? In that one, we have 2. So can we have smaller? In that one, we have infinite. Can we have smaller? كده أوضح. Okay, so we have 2 and infinite value. That what I'm looking for. So how can I find it? That is the trick that this scientist Floyd came up with that one. What is the trick? I am talking about D1. So 1 is the critical value here. What does it mean, Mr. Shaikhan? It means the following. I am looking for the value or a shorter value from 2 to 3. From 2 to 3. Okay, so in order to do that, how can I find a smaller than 2? You will do the following. 1 is the value that I made it fixed. So can I have a value from 2 to 1 plus value from 1 to 3? See now, I'm looking for 2 to 3. I did it in this way. I put 1 as what? In between. So from 2 to 3, I will go first to 1. From 1, I will go to 3. That is the trick of algorithm. If you understand that one, we are done, by the way. خلاص. Question so far? Is it clear? Any questions so far? Everything is all right? Alhamdulillah. Okay, now from 2 to 1, what is the value? That is 2. That is 1. So the value is 1. From 2 to 1. The value is 1 plus. What is the value from 1 to 3? What is the value from 1 to 3? From 1 to 3 is 7. From 1 to 3 is 7. So the answer is 8. Now, the original 2 to 3 is 2. So it's very clear now that 2 is less than 8. So keep it. We cannot find the shorter value. Clear? Any questions here so far? Okay. Now, what is left? 3, 2, that one. ممتاز. Now, we need to find, can we find a value less than that one? Let's see. فين عشان أعيد لكم إياها مرتبة. Yes. Okay. Let's look now at the second point اللي هي which is I'm looking for 3, 2. So that is 3, 2. The current value is infinite. Now, from 3 to 1, what is the value? Plus from 1 to 3, what is the value? With the same idea, I'm looking for 3, 2. عفوا في خطأ هنا بسيط. From 3 to 2, 1 to 2. Okay, I'm looking from 3 to 2. So that is 3 to 2. Then from 3 to 1, then from 1 to 2, from 3 to 1, from 1 to 2. Now, what is the value from 3 to 1? 3 to 1 is 6. So that is 3 to 1 plus. What is the value from 1 to 2? Exactly. From 1 to 2 is 4. So now the total is 10. Question. Which one is smaller? Very clear now. 10 is smaller than an infinite. So now that value will be 10. Okay, that value will be 10. Let's check our answer. So 2 kept, 10 is the new value. That is the whole idea of Floyd algorithm. So now, from, as we said, 3 to 2, from 3 to 2, no way, no path. So how can I reach there? One of the solutions that you can go 3 to 1 first, which is 6, which is that one. Then from 1, I can go to 2, which is 4, which is that one. So now I have a better solution. A better solution. From there, it came 10 and 2. Clear? Any questions? Any questions so far? Excellent. ممتاز. Next. Control N. Next. Next, you will start. Alhamdulillah. So far, so good. Excellent. Now, you will start from where you stopped. I stopped here. So let me draw it now, starting from that one. So now I'll go to D2 actually, but I will start from here. So now that is the values of my current situation. Now, all of you now will expect that since I'm talking about D2, so I have to make row 2 fixed. So 1, 0, 2 will be fixed in D2. And also, I will make column 2 fixed. So column 2 is 4, 0, 10. That is 4, 4, 0, 10. طبعا again with the same idea. هنا 1, 2, 3. 1, 2, 3. Diagonal. Very clear now. From 1 to 1 is 0. From 2 to 2 is 0. From 3 to 3 is 0. What is left? That one and that one. Question. Can I come up with smaller values? The current value is 7. Can I come up with smaller? We will see. And that one. The current value is 6. Can I come up with smaller value? We will see. We will see. Okay, let's go. The first one, which is 1, 3. 1, 3. If current value we said is 7. Now, to do that, what should I do? Fixing is 2, so it will be from 1 to 2. Then from 2 to 3. So from 1 to 2, from 1 to 3. So 2 is the middle here. Tamam? Now, from 1 to 2 is 4. From 1 to 2 is 4. From 2 to 3, from 2 to 3 is 2. So the value is 6. So that is smaller. That is smaller. So 6 will be there. Accept? Excellent. How about that one? That one, 3, 1. The current value is, anyone remember? 6. Okay, the current value is 6. Now, to solve that one, I will go from 3 to 2. Then from 2 to 3. 3, 2 is 10. 3, 2 is 10. It's very clear now. Okay, from 3 to 1. So 2 will be in the middle. So 3 to 1, 3 to 1. Tamam? 2 in the middle. You are right. Okay, so now 3 to 2, 3 to 2 is 10. And 2 to 1 is 1. So that is the answer, which is 11, which is greater than 6. So 6 will remain there. So that is my current solution. 6 and 6. That will, okay? 7 now became 6. 6 it remain as is. So no change. No change. Now, let's see it here in the figure, in the map, in the graph. Now, from 3 to 1, from 3 to 1, from 3 to 1, what is the path from 3 to 1? From 3 to 1, from 3 to 1 is 6. Okay, now, and from 1 to 3, from 1 to 3 is 7. From 1 to 3 is 7. So now we found a better way that I will go in different way. اللي هي طبعا very clear هنا. اللي هي which one? What is the way how to reach one with shorter? عفوا, how to reach 3? Sorry, from 1. How can I reach 3? Instead of going from 1 to 7, now I have to go to 2, that is 4. Then I will go to the 3, so that is 6. So it is better for me to go through 2. Questions so far? Last one. Exactly the same idea. Now I am talking about, طبعا عشان ما نمسحها, because it will be the same. So let's draw. Okay, now in order to do the last one, so D2 D2 will be the base for that one. Now, I will make row 3 and column 3 fixed. So what is left there? If it is those ones are, so what is left? Row 3 عفوا fixed, column 3 fixed. So now I need to find, is there a better value than 4? Is there a better value than 1? That's what I'm looking for. طبعا 0 0 will be the same. So do you think that we can find a better value here? Let's see. Let's see. From 1 to 3, to 2 عفوا. From 1 to 2. That one. So it will be from 1 to 3. Then plus from 3 to 2. What are the values here? 1 to 2, the current value is 4. The current value is 4. From 1 to 3, 6. طبعا very clear, I can reject it from now because it's bigger. And 3 to 2 is 10. طبعا done. No change. It will remain 4. How about that one? From 2 to 1, current value is 6. From 2 to 3, plus 3 to 1. From 2 to 3, right now, that is 2. And from 3 to 1, that is 6. It's very clear that it will be rejected. Okay, it will be rejected. طبعا هنا plus. Okay, it will be rejected. So it will remain 1. 1 هنا عفوا. 2 to 1. 1. So it will remain 1. It's not 6, it's 1. So no update, no changes. That is basically the idea of Floyd algorithm. Okay, any questions? طبعا that is the code that might be done. ممتاز. Okay, how about if we have negative values? Same idea, with no differences. Okay, now my table, I can go from anywhere to anywhere with the shortest path. Since you reach to the last one, so now you can go from anywhere to anywhere with the shortest path. The best example actually that I can go direct from 1 to 3 in 7 hours, let's say that. But now I found a better way that I will go to 2. From 2, I will go to 3. That is 6. So that is minimum. That is the minimum. Okay. With negatives, exactly the same way. It's matter of calculations. Okay. Now, can I do it for any number of vertices? Sure. Exactly. Sure. So you will build D0, 1, 2, 3, 4, 5, 6, 7, 8, whatsoever. The same 1, 2, 3, 4, 5, whatsoever. And then you will set the original values. If there is no way, infinity. Diagonal, all of them zeros, as you can see. All of them zeros, as you can see. And then you will start one after one. You will start with D1. So now row 1, column 1 fixed, and so on, and so on. We are done with the most, I'm talking about the course as named analysis of algorithm, okay, and data structure. That is the last algorithm we have, okay. Now, for a few minutes, we will go with some very theoretical part. When we talk about dynamic programming, there are several ways to solve any problem. light here. We might use a brute force. We might use greedy algorithms. We might use divide and conquer. We might use dynamic programming. Actually, it is sort of how to solve something. Optimization programming. Okay, so now if we look at back to dynamic programming is an algorithm design technique. So it is a technique. It is a way for optimization problems. Minimizing or maximizing programming here means planning. Example, like divide and conquer. That, by the way, is another way of solving, but it says like. Like means it's similar in the idea with little differences there. So dynamic programming solves problems by combining solutions to subproblems. So instead of taking the problem as a whole and solve it, we'll say, no, let's divide it into subproblems. Can we solve it now? We can solve it, but it will be better if we keep dividing. Just to remind you about the idea, when we talked about merge sort, let's say that we have that number of numbers. So I want you to solve that problem. What is the problem? Sorting these numbers. You can use bubble sort, you can selection sort, you can use quick sort, you can use insertion sort, and you can also use merge sort. So in that one, we will divide that one. So how many ones are there? It will be divided into two parts. Then that part, how many ones are there? How many ones are there? So it will be divided into two parts in the next step. So you will keep dividing until you reach to the smallest one, 2. Now compare between the two. Merge it with others, the other 2, which is here, right here. So now just merge between 2, afwan, compare between the 2, and then merge them in 1. So that one is the merge sort. Divide, and come back, then merge. So that is the idea, basically. So you have some sub-problems. What is the difference? Unlike divide and conquer, sub-problems are not independent. They will share sort of values, variables, with the others. So it's not independent. This cannot be solved by itself. That is basically the idea of dynamic. Dynamic programming reduce sort of computations, okay, if they use a bottom-up fashion. Sometimes top-down fashion, depends on the cases here. Steps in dynamic characterize structure of the optimal solution, define values of optimal solutions recursively, compute optimal solution values top-down or bottom-up. Are you coming up to down or from down to up? Then construct an optimal solution for the computed values as a whole at the end. Example here, we did talk before about the Fibonacci numbers. What is that? If you have numbers, then first, second, that has special case. F0 is 0, F1 is 1. So I can do nothing about that one. Now, after that one, which is the third one, is the sum of the previous 2. Okay, so Fn is the sum of Fn minus 1, Fn minus 2. That is the problem, the case of Fibonacci. So you will keep going now. Now, if I ask you what is value number 4, it's supposed to be 2, which is the sum of the 2 previous values, 1 and 2. So that third one will be 2. What is next? 4, which is 2 plus no, 1 to 2 plus 1, 3, and so on. So every time you will take the previous 2. So you will divide the problems into sub until you reach to the last one, depending on how many numbers do you want to have, what is the value of n. 100, so 100 will be what? 99 plus 98. 99 will be 98, 97, and so on, and so on. That is the idea of dynamic paradigms of algorithms. Brute force. Brute force, basically, search for exhaustive values or generate and test. If you forgot a password, or if you wanna hack a password, crack number, serial number, whatever, so you might use that one. You will keep searching so that you know that, or even you don't know that the password is minimum 3 numbers. It could be more, it could be less. So you will start from the minimum one. And you will start say, it could be zeros. I think we talked about that. If you have a bag that contains, or suitcase that contains numbers, you forgot the numbers, so you cannot open it. So what you will do, you will keep trying. 0, 0, 0, not working. 1, 0, 0, still not working. 2, 0, 0. So what is the maximum number that will let you reach to the correct number? Exactly. So you keep trying. It's not necessary 99. Maybe you are lucky and you find it from the first time. 0, 0, 0, open. Okay, that is the idea of the brute force. Greedy algorithm. The solution is constructed through sequence of steps. At each step, the next optimal step is selected locally without considering whether this step leads to the final or not. Simple example here, crucial digester. We talked about them last meeting. Divide and conquer. Maybe the best example is the merge sort. And we talked about that. Also the quick sort, but merge is more obvious. Dynamic programming, today's algorithm, Floyd. Optimization is the selection of best element from set of available alternatives. Okay, in general, optimization includes finding best available values of some objective functions given defined domain or input. طبعا at the end you might solve a problem with several ways. I can solve a problem مثلا directly, and I can solve it in recursive way. So at the end, if I can find the solution that what is wanted, but sometimes finding solution is not my goal. My goal is to find the most optimized one, the most efficient one. Example, genetic algorithm and colony algorithm. طبعا, by the way, we have hundreds of algorithms. Go to the YouTube and check hundreds. And in this course now for almost 5 weeks, we are talking about algorithms is the well-known algorithms. The well-known algorithm, but we have hundreds, maybe thousands of algorithms that is available there. Types of problems: B problems, MB problems, NB complete problems, MB hard problems. Very quick. B problems, easy, can easily solved by a computer. Very simple one. It's a matter of yes, no. Okay, so easy to understand, easy to be solved. That's type of problems. NB problems, still easy to verify, but hard to be solved. Hard to be solved. I might give you an idea, and okay, the idea is very clear. But in order to solve it, it will require a very complex computations. It will require, but you got the idea. يعني the idea is very clear. The idea is very clear. But how I can solve it, that is problem. The first one, both of them are easy. Now, MB complete problems are special kinds of problem. You can take any kind of MB problem and it can ask what is the best way to stuff مثلا a knapsack اللي هي هذه البروبلم knapsack problem. So it is difficult to understand or difficult to be solved. Or even if sometimes you reach to a solution, you had to verify it. You cannot take it for granted. Example, when we talked about digestera, we said you have cities, that is Riyadh, then I need to calculate the area from Riyadh to Dammam, Riyadh to Jeddah, Riyadh to Ha'id, Riyadh to Medina, and so on. Okay, now, the idea very clear. Is it easy to be solved? No, because I have to do that computationally. I have to write a program now. So in order to program, what is the algorithm that I will follow? When I say search for a number, the idea is very clear. Can I search for it? Yes, I can search. I can use sequential. Are you the correct one? No, 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 yes. So that is sequential. Or use a binary and so on. So that is the idea. Some of the questions easy to be solved, easy to be understood, but difficult to be, and some of the problems, no. Back to digestera. If someone give you minus, and he said solve it by the digestera, it will give you an answer. It will not stop, because minus 3 is a number, as I told you. So 7 minus 3 is 4. It will work. But is it correct? No. That's why negative, they came up with the idea later on when they discovered that problem. They said it is an excellent algorithm, but don't use negative numbers. Last one, MB hard problems are worse than MB problem. Even someone suggested the solution to MB hard problem, it still take forever to verify it. You will never reach to say it's correct or no. You will never reach to if it is yes. طبعا one day might be reached if we have a very powerful computers and processors. That's it for the types. Last for today. Do you want to take 10 minutes break? Would like to take 10 minutes break or continue? ما عندي مشكلة. Both working with me. Continue and finish. Let's go. SQL. That's a very important topic. Very important topic. يعني I suggest you, especially for those who would like to, inshallah, يعني continue with programming in general. Okay? In general, it's very important topic. You must master that one. You will find it almost everywhere. Okay. SQL is structured query language. Okay, it's divided into some sub concepts. One of them is data definition language, DDL. Okay, like when you create a table, for example, you will alter structure when you delete something. So generally that is at the beginning, or rarely, seldom to be used or applied. So now I will create a table for our, let's say, database for hospital. So you might sit back and think, what tables do I need? So you might say, I need our table for patients. What do you need in the patients? We'll come to it. What else? I need table for doctors. I'm talking about database. What else? I need a table for nurses. What else? I need table for appointments if the patient want to make an appointment. What else? What else? What else? So in database, if you want to develop an application, app, website, whatsoever, so you need to think in that way. Now you will come to the patients. New patient is coming to the hospital. So what sort of data do we need for that patient? We need to give him a number, okay, patient number, like you have student ID, for example, and we need to know his name. We need to know his date of birth. We need to know his nationality. We need to know his address. We need to know. So you will analyze, you will study that one. The same for the doctors. The same for the doctors. The same for the nurses. The same for the appointments. Then you will start building the relations between them. So the patient wants to visit a doctor. So that is the relation. So X will visit Y. And also he needs to make an appointment. So he will make an appointment here. So patient X has an appointment Y, which is Sunday, 29 of June at 4 p.m. So that is the relations between. So that's why they call it relational database. Relational database. The rest is the rest. Okay, so that you will do it as what? As a definition. Then you will talk about data manipulation language. That is mostly every day you will use it based on that one. For example, you need to know all the patients who visited the hospital today or yesterday or last month. So basically, you will do a query. That's what it said, query. It is select all patients who visited the hospital on June 29, 2021. So it will give you a list of that one. From here, it comes the importance of SQL. If you have a good relation between the tables, you can come up with any data you want, in the hospital. All the patients who visited that doctor in the last 5 years, you can bring that report. Okay, so far so good. So that's why Anna myself, I love that topic. Database management system. You have database. That is your database. Okay, database is a collection of tables, and then tables is a collection of what? Columns, اللي هي fields, attributes, and then finally the rows. Exactly. Data. Then you will come up with the information. So that is the database. Then this is your job, database manager. Control access to database. Who should access there? What are the permissions? Is there data integrity? What are the access service? So now that will be done for whom? For the client. So in the reception, they need sort of permissions so they can access the database. مثلا new patient came. So what is your name? Give me your ID. They will take date of birth. They will take a nationality. So what is your address? So what is your mobile number? What is? So that is in the reception. So he's a client using database manager in order to access the database. Now, how about the doctor? Doctor also a client. But what sort of permissions? He can look at the patient records. What is his health problem? That permission, the reception cannot see it, and so on. Okay, and so on. So that's basically the whole story of a database management system. Client server database. So we have a server, we have a database in that server, we have clients. Clients, not necessary that they are in the same place. Okay, it's not necessary that they are in the same place. Now, me and you, we are clients of what? Clients of servers of Arab Open University. Now, if I go to the email, for example, now there is an email for staff, there is an email for LMS, same idea. I have my own permissions, you have your own permissions. SIS, I have my own and your own. See, look now, for example, just as an example, this is the SIS. From the SIS, I can look at any student, okay? Just give me his ID number. Okay, give me his ID number. I will give you the details of that student. So that permission, not for student. Okay. Data types in SQL. It's like programming, as I told you. Programming, you need to look what sort of data type I have. Integer numbers, strings, double or float, or decimal numbers, okay, and so on. Date, time. So those sort of. Next, tables. As I told you now, patient is a table and contains fields, attributes. So that is a product table named, we need bname, what is the price, category, manufacturer, and so on, and so on. Tuple is a record. Gizmo, مثلا, that is a record. That is a field or attribute. Rows and columns. Rows and columns. Table is a set of records. Students records. Patient record. All of them in one table, which is the main container of the students. So that is a table of students and so on. والله كلمتكم في الأول أنتم رفضتوا. فخلينا نكمل، ما عاد بقينا الا قليل، معلش سامحني او سامحيني. اوكي، انا والله خيرتكم، فالان احنا اوريدي ما بقينا الا قليل، خلاص يعني نكمل هذه ونقدر نمشي ان شاء الله. اوكي، next. Then you will start from there. طبعا there are many properties and also many operations. Can I go to the first record? The schema of a table and the name of the table, product or patient or students. So what do I need there? What information I needed? That one should be studied carefully, very carefully, because it will be very costly if I remember later on that I missed one of the columns. For example, if I designed the patient table and I set everything, well, I said that's excellent based on analysis, evaluation, testing, everything. So when I started my application, I discovered that I did not added a column for the insurance company. Are you insured or not? And if yes, what is the name of the insurance company? Let's say that. So now, in order to do that again, it will be very costly, very costly. So that is sort of how to think about it. Then we have a key attribute. طبعا this is not the right place to check all the cases. We have, if you took 354, so we have, for example, primary key. We have a foreign key. ما أدري إذا مرت عليكم هذه ولا لا. Have you ever heard about that one or not? Primary key, foreign key, candidate keys, and so on. So key, all the time, in any table, there must be a key. What is that key? The value of that one will never be repeated. So if you are a programmer in a hospital, the first patient came, you give that patient a number, that this is your patient ID. So that one should not be repeated forever. Like student ID. Now you are in the Arab Open University. You have a student ID. That is the key. Will never be repeated. Will never be repeated. The same for your passport number, the same for your Iqama number, the same for national ID, the same for driver license, the same for everywhere. So that's what we call it usually. It's a key, and usually we call it primary key. So that one whose value are unique will never be. طبعا they suggest to make underline. Again, this is not the course that we will go into deep details. Now, everything is okay, everything is done. That is the most used instruction or query. أكثر واحد استخداما هذا من تجربتي. Okay, all the time you will work with that one. Now, what it says, select from where. طبعا, is it necessary where? No, it's not necessary, because you might just want to take all students. So you can just say select from, that's it. Okay. طبعا you can make it more than that. Inshallah, you'll study it somewhere. بإذن الله تعالى. So select the attributes from, if you exactly, Access has that one, PHP has that one, or many others. So select attributes. Now I need to look at the patient's data. So do I want all the fields? No, it's enough to look at the patient name, okay, and the name of the doctor, or the name of the clinic, or just the name of the insurance company. And just I want to take a decision, for example, from there. So now it's enough to select patient name, insurance company. So that is select attributes. From where? Very clear here, it will be from the patient table. طبعا I can make a very complex, advanced, sophisticated query if I take from more than one table. مثلا, you have transactions. So that patient in that visit, how much he paid. But did he visit the hospital only one time? No, it's about 100 times in this year. So how much he paid throughout the year. So you can do something like that. طبعا from, it could be from several tables. And do you have a condition or not? Condition like, I need all the patients who visited the dentist doctor. So I don't care about the others. So that is a condition. I need all the patients who visited the hospital in June. Others, I don't care. So that is the where. This is a very powerful one, very powerful. Here we have tables. Here's the what kind of query we can have. Select asterisk. Najma. What does it mean? All. From product. So I need all the data from product table. Now, is there a condition? Yes. Only if the category equal gets. So that is the answer. That is the answer. طبعا maybe in the exams, طبعا في old exam, they used to bring something like that and check. Did you understand the idea of queries? Yes, I understood. Select Najmas, select asterisk. It means all the columns. So it's there. That is the solution, all. Now, from product, if you have several tables, so is it from all tables, some of them, only one? It's only one product. Now, is there a condition? Yes, category must equal get. So the output is that one. Yes, yes, ignore. So that is the answer. That is the result. That is the output. Okay? Now, what is the condition? Anything you want. Look at this one, we'll make it inshallah clear. Select B name, price, manufacturer. So I don't want all the columns. It's enough to show me 3. So now in this one, I skipped category. It's not there. From product. For all, no. Only if the price is greater than 100. Greater than 100, no. Ignore. Greater than 100, no. Ignore. Greater than 100, yes, add it. Greater than 100, yes, add it. So that is the output. I think inshallah انها clear باذن الله. I hope so. Okay, where we'll take any sort of conditions, greater than, less than, equal, alhamdulillah, equal, like. طبعا it's the يعني, by the way, it's a language. It is a language. يعني you can do very amazing reports there. Amazing reports. Okay, that is basic. But again, it's not necessary numbers. It could be characters, it could be strings. I need all the patients from Jeddah. All the patients from Mecca. Because I will, inshallah, start new business in Mecca. So I will have another branch there. So now I will just select all the patients in Mecca and send them a message. It's like tell them, Alhamdulillah, congratulations. Now you don't need to come to Jeddah. We have a branch in Mecca. يعني أهل مكة ينزلوا جدة مثلا عشان السعودي الألماني مثلا. Okay, مستشفى السعودي الألماني. So now we have Saudi Almani in Mecca. For example, I'm just give you example to make it clear. Okay, so now you can search condition any sort of data. Like operator. Like operator, very interesting one. Very interesting one. Now, I work in Danube, in big, huge supermarket. So now, they have hundreds, maybe thousands of products. So I'm looking for a certain product. So you can do that using the like operator. By using that operators. اللي هي example هنا. When I say select, it means all. From, it means from that certain table. Look now at the where. Look now at the where. Where? Product name, B name, like. Like what? Percentage, gizmo, percentage. Can anyone guess what is meant? Anyone, can you guess what is meant? Just guess.
Big gizmo only.
Only. طيب اعكسها معلش. Make الopposite. اعكس لي اياها.
Big everything except gizmo.
مرة كده لا أول أحسن. The previous one is better. Okay. If I said مثلا names. في names. We have Ahmed, we have Anwar, we have Muhammad, Mansour, okay, and so on. So if you said, okay, M, it means show me all the names that contain M. Regardless what is before, what is after. هذه what is before, what is after. You remember when we search for a file, we put asterisk, فاكرين? Asterisk. What does it mean? What does it mean? All. Okay? All. If you said asterisk, but this time I wanted to be doc. So what does it mean? It means all files just for Word. That is a Word files. But here no, all. Word, PowerPoint, Excel, and so on. So that is the idea of the like operator. So you have hundreds of cheese product in the supermarket, all types, all sizes. So it's enough to say I'm searching for مثلا خلاص, it's enough to say that. So what will happen? It will bring all the values that contain CH. طيب I wanted to start with cheese. هنا difference. So you will make it CH then percentage. So now must start with CH. Then I don't care about the others because you know that cheese will come there. Unless you have another product also start with CH. So you can make it more precise. So you will add مثلا whatsoever. هذه ببساطة idea of the like. تمام? So it should bring all those cases distinct. Now I need to know the cities, the nationalities. في حالة students, GPAs, anything, but in distinct value. Distinct means what? Distinct. مثلا, I need to know the nationalities of the students in AOU. So, I will make it like that. Select distinct nationality, NAT, if it's named NAT or nationality, okay, from students. In that way, do we have Saudis in AOU? Yes. So it will just give me number one Saudi, regardless of how many distinct. Now, do we have Egyptians? Yes. It's enough to say Egyptian. Even if you have many. Do you have Palestinians? Yes, we have. Do we have Jordanians? Yes, we have. Do we have Yemenis? Yes, we have. Do we have Pakistanis? Yes, we have. Do you have Indians? Yes, we have. So it's enough to give me distinct value. That's also very important. That is also very important. Eliminating duplicates. Next, select, very clear now, inshallah, what data you want to display, which table you want to display, and is there any condition? Yes, I'm looking for the category gizmo. And price greater than 50. So now it's not enough gizmo. Gizmo, it means without that one, it will bring everything. No, I'm looking for also gizmo and prices. So you know the situation here. True, true, false, 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 true, and so on. And order by price bname. So it will sort based on price, then bname. إذا هنا الأوردر باي for sorting. Is it ascending or descending؟ تصاعدي ولا تنازلي؟ الديفولت ascending. If it is not mentioned, ascending. If we specify disk, it means descending order. So if I need it in descending order, I have to say that. I have to say that. If it's just ascending, no need to write anything. Select category from order by name. So now you will notice that the name should be ordered. It's not ordered here because start with G, P, S, M. So it has to be ordered. It has to be ordered. Join. Join, it's a little bit now not difficult, but it's more complex. That you will connect between two tables. Now, I need list of products. But I need to know what are the origin, the country, the factory مثلا of that product. So, gizmo, wallahi, I don't know. It's not written here. The manufacturer is that one, but from where, I don't know. So in order to know that data, I have to go to another table. So I will know that it is from USA. And so on. And so on. So there must be a connection between the two tables. That's what we call it, the relation. There must be a relation. So from here, I can go to some other tables. Inshallah, في مشروع التخرج تبعكم, you have to build it very carefully. Inshallah, in your final project. بإذن الله تعالى. بإذن الله تعالى. Okay, now look what it says here. I have a product, I have a company. Now select bname and price. Now from, I have two tables. Two tables. So it means I will bring data from two tables. Now, what is the thing that will make the join? So I need to patch manufacturer مثلا CNAME والcountry must be Japan and the price is less than. طبعا هنا حتلاقوا اللي هي برضو another example. There must be a relation between the two. There must be a relation between the two tables. لازم. So now you will get data from several places. From several places. طبعا لاحظوا هنا bname price from product. But in order to check if it is from Japan or not, you have to go to that table. Okay, so the data will not show Japan, but I use it as criteria. Okay, as a criteria or in my criteria, in my condition. So I have to go there and check. That's why I have to include the company table. Company table. Now, an example will work here, regardless of. So now I'm using product and company again, but now with different criteria or condition, different criteria or condition. Okay. If I use that one, select country, product, company, manufacturer name, CNAME, and category get. So now that is the case. That is the case. So I have to check for the values, and I have to check if is that category is the same. We will be get a country, because what is wanted here is a country. So look now, where is the country? In the company here. The company. That's it for today. you have a question, you remain. If you don't have a question, we are done. You can go and do anything you want. But we are done for today's lesson. But I am here with you unless you don't have anything you want to share. أي سؤال، أي استفسار، أي اقتراح. Anything you want to share with me? أنا feel إنكم مرهقين جدا، ترى ملاحظكم الأسبوع هذا. في شيء شاغلكم. You are welcome. خلاص وصلتوا حدكم النهاية. يلا هانت ما بقي إلا أسبوع ترى على فكرة في الترم. خلاص الجداول حتظهر في اليومين هذه باي ذا واي. خلاص بإذن الله نقول بإذن الله إنها تيكو يوم إكزام بإذن الله تأكدت خلاص تقريبا يعني ممكن. لا ربنا يكرمكم إن شاء الله. لسه في وقت على الواجب وفي وقت على الكويزز. أنتوا لسه أخذتوا 3 كويزز still have 2 و still have 50 for the final. So أنتوا نحن نتكلم عن 50 plus 20 70 and 2 quizzes 12. We are talking about 82 marks still in your hand. 82 marks. 50 للفاينل و 20 للتيم A that is 70. تمام. و you still have 2 quizzes that is 12. So still early يعني. still early. إن شاء الله ربنا يكرمكم إن شاء الله بإذن الله تعالى. سؤال، استفسار، question, anything, any doubts؟
دكتور
آمر.
ما أمر عليك صارم، الصوت انقطع شوي. الآن علامة النسبة المئوية هي تعني كونتين. مثلا كتبت CH علامة
نسبة مئوية. هي
أنا تبدأ ب CH صح؟ تبدأ ب CH وبعدها أي شيء.
بالضبط. هي بديلة للأستريكس. هي تتذكر. خلينا أشغل لك الشاشة. تتذكر زمان نحن لو جبنا أي هنا شايف هنا بنعمل مثلا نحن فين في أي مكان في ديس بي سي مثلا. أوكي لو قلنا له هنا أعطيني نجمة دوت دوك. تمام. وطلبت منه سيف. الطبيعي إنه يبدأ يبحث عن جميع ملفات الوورد. شايف؟ لأنه قلت له نجمة دوت دوك. ليه ما جاب لي اكسل؟ ليه ما جاب لي باوربوينت؟ ليه ما فهي نفس الفكره هناك بس برسنتج. سيم ايديا. وصلت؟
وصلت.
نفس الله يبارك لك. الله يبارك. Any other questions؟ الفاينل تقريبا انا يعني تقريبا بس شوفوا حيظهر علني بس يعني انا بقول لك الان رفلي الفاينل إن شاء الله بإذن الله تعالى. قول يا رب. هذا بروبوز الآن إن شاء الله إذا يعني ابتدى. الفاينل غالبا حيبدأ يوم 25 جولاي. متى 25 جولاي؟ 25th of July. يعني بعد الحج. يس بعد الحج 15 ذو الحجة. إن شاء الله إلى يوم آخر يوم في الاختبار أوغست 2 إن شاء الله. طبعا it will be announced يمكن by tomorrow. لا والله أنا my concern هنا إنه the good thing إنه